In grade 9, we gave you guys equations. The equations looked like this. Y equaled x plus 2. Right? Ease bees, lemon squeezy. We told you to put it on a graph. How do you put it on a graph? You made a t-chart, right? You always made a t-chart or a table of values, whatever you called it. You chose the x and the y and you put them in there, right? So, I told you should always pick 3. So, give me 3 numbers. That's one number, dude. 1, 2, 3. Okay. 1, 2, 3 are inputs, yes? How do you know what numbers to put in the y column now? What must you do? It's not a trick question. What must you do with 1, 2, and 3 to know how to finish this chart? Huh? You need to take this x, put it there, right? So you would put 1 there, you would put 2 there, and you would put 3 there. And that would get you 3, 4, and 6, right? That's grade 9. Everything's cool, yeah? These are inputs. These are outputs. Oh yeah, 3, 4, 5. Sorry, thank you. 3, 4, 5. Outputs. These are outputs. How do we get our outputs? We do math to our inputs. Right? That's how it works. Everybody knows how to do this, correct? So we could write this as output equals input plus 2, right? Because that's what we're doing. We input, we add 2, we get an output. But this is not how math people like to write things. Why? Because it's ugly. It's long. Math people don't like writing a lot of letters. So they invented function notation. And that is as follows. Output gets renamed as fx. And that stands for function of x. What does that mean? X gets math. So instead of writing y equals x plus 2, we have evolved to writing f of x equals x plus 2. And we read this as f of x. Function, math, that is happening to x. The f is the function's name, because you can only do one set of math to this x. So this is f of x. No matter what I put in for x, I'm going to add 2. So the table of values now is no longer x and y, it's x and f of x. Input, output. Madeline. We're getting to that. This is what it looks like now. Does anything else change? No. X's are still there. I still use 1, 2, and 3. My outputs are still 3, 4, and 5. Nothing changes. All right? Now, is it possible to have more than one equation that we are working with? It is, isn't it? Just like there is more than one student in here to whom I am teaching, right? What differentiates that kid from that kid? Because if I blindfold myself, they're just kids. What differentiates you people from each other? What is the thing that is your own that is not anybody else's in the room? Pardon? You all look very similar to me. You have 2 eyes, nose, ears, hair. Name. Name is what differentiates you from each other, yes? This F is the name. So, if I have another equation, I can't use F. So we would use another letter. G of X, H of X, I of X. That is all just naming the equation. Everybody good? All right. So if we were in the 9th grade, which none of us are, this is set up like we set it up in the 9th grade, right? With a y and an x. Our table of values is set up with a y and an x. We've been given inputs, right? So what would I do with that -2? How would I do this line? And I will use this color blue for it. What would I do? What would you do to tell me this empty spot? Sihaj. You would put -2 in for x, right? So y would equal 1/2 of -2 minus 2. What is half of -2? He waited patiently. Thank you. -1 minus 2. What is -1 minus 2? -3. So y would equal -3. And then we would do the same thing with all of them. Y would equal 1/2 times 0 minus 2. So y would equal -2. Y would equal 1/2 of 1 minus 2. So y would equal -1.5. And finally, y would equal 1/2 of 4 minus 2, which would be 0. All of you can do that, right? The only difference is instead of y, we now write this as f of x equals 1/2 x minus 2. And instead of just subbing x in there, we have to sub it in everywhere we see an x. So, if x is -2, what do I see right there? -2. So I input -2. If that x is -2, what is that x? -2 minus 2. And I get an answer of -3. So the f of -2 equals -3. On our graphs, that is the x value, because it says so right there, x is -2, and that is the y value. But otherwise, nothing changes. The only thing that changes is the way we write it down. It's kind of like how when you were in kindergarten, you wore different clothes than you wear now, but you're still the same person. Okay? It's just different looking. It is the exact same math. And yet, people have trouble with it. That's kind of like saying, well, if I add even numbers, I know how to do it. But if I have to add odd numbers, I'm screwed. That's stupid, right? None of you would say anything like that, so none of you need to worry about function notation. It's just a different way of writing it. So let's look at our very next one here. You see this, but you know that it's, if this was grade 9, this is the same as y equals 2x minus 7, right? But you're not going to see it written that way anymore, very rarely. You're going to see this, but nothing changes. What did the x become here? 2. What did the x become here? -3. So this is just like doing the input of 2 and the input of -3. So the first thing I do is my input of 2. It is not f of x anymore. What is it? F of 2. So that x became 2. So what does that x become? 2 minus 7. What is 2 times 2? 4 minus 7. What is 4 minus 7? Negative 3. What is the point on the graph that we would now use? 2, negative 3 is the point that would go on the graph. Everybody understands, yes? Okay, so what is happening on this next one? It is not f of x anymore. What is it? F of negative 3. Now, that x has become a negative 3. So what does that x become? Negative 3 minus 7. What is 2 times negative 3? Negative 6 minus 7. What is negative 6 minus 7? Negative 13. And what would the point on the graph be? Negative 3, negative 13. Is everybody good? It's very easy. 90% of you have seen it before. In reality, 100% of you have seen it before, because the only difference is, instead of writing y, we're writing f of x, or g of x, or I of x, or q of x, or whatever. Right? Okay. Turn the page over. I have an equation. And what are these three values? Are they x's or are they y's? Those are x's. So how many times do I have to do math to do this question? Thrice. I have to do the g of 6. What do I write here? Negative 2/3 times 6. Now, it might help you to write 6 over 1 plus 1. What is negative 2/3 times 6? Pardon me? Pardon me? Pardon me? Negative 4 plus 1 equals negative 3. What is the point on the graph? 6, negative 3. Then, what's the next one I have to do? I have to do the g of negative 3. What do I write? Negative 2/3 times 3 over 1, negative 3 over 1 plus 1. What is negative 2/3 times negative 3 over 1? Positive 2 plus 1 is 3. What is the point that I will put on the graph? Negative 3, 3. And lastly, I need to do the g of 0. So what do I draw? Negative 2/3, or what do I write? Times 0 plus 1, which is what? 1. What is the point that will go on the graph? 0, 1. And now all I do is I put my points on the graph. 0, 1. Negative 3, 1, 2, 3, 1, 2, positive 3. And 1, 2, 3, 4, 5, 6, 1, 2, 3. Now, is it a straight line? Yes. Is it continuous? Yes, because I can put any number in for x, multiply it by negative 2/3, and then add 1. So I must connect the line. And you will pretend that that line is perfectly straight. Just like when you hand it in to me on a test and you don't have a ruler, I will know that your line is perfectly straight. Everybody understand? So easy, right? Nothing new, nothing complicated. This over here is function notation algebraically. Forgot the I. Algebraically. This over here is function notation graphically. You have to be able to do both. Okay? So, let's do the algebra one first. Using the same information for number 3. So I'm going to rewrite it right here just so it's right in front of our eyes. Negative, gx equals negative 2/3 plus 1. 2/3 x plus 1. Now, when I knew what x was, I put it for x, yes? What is different here? Do I know what x is? No, it's still an x. But do I know what g of x is? What is g of x? 7. And I can quite plainly see that right there I have written g of x, haven't I? So if I were doing algebra, what would I write there instead of g of x? 7 equals negative 2/3 x plus 1. What is my job whenever I am faced with a single variable? Isolate it. So we're going to do some algebra. What happens to plus 1? Minus 1. Some of you will want to write negative 1 and negative 1. That's cool. Some of you will just move it over here and say this is 6 equals negative 2/3 x. Do I care how you do your algebra? No, as long as you do it right. What needs to disappear now? You got to get rid of the divided by 3, right, Damon? How do I get rid of divided by 3? I'm going to multiply by 3. Do I have to get rid of this negative 2? I need to get rid of the negative because I need x to be by itself, don't I? So can I get rid of the negative and the 3 in one step? How? I multiply by negative 3. So now I have negative 18 equals 2x. Now what? Divide by 2, and x equals what? Negative 9. What would be the point on the graph? Negative 9, 7. Everybody good? That's algebraically. We also have to be able to work graphically. So I'm going to change color to green, and we're going to work graphically. This number right here, is that an x or a y value on our graph? That is a y value. That is the same as saying y equals 7. Where is y equals 7? Somebody talk my little pink circle here to where y equals 7. Straight up. How far? 1, 2, 3, 4, 5, 6, 7. Right to there, right? Everyone agree? Now, what do I know about that line that I drew earlier? What do I know about that line that's going through those 3 dots? I know some stuff about it. What do I know? It continues. For how long? Infinity. In which direction? Up and down. So this line that I had right here, oh, that's supposed to be a straight line, you piece of garbage. Erase, 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 erase. This straight line continues forever, yes? Through those dots, agreed? What do you see? Oh, it just erased. What do you see right there? Does it cross 7? It does. And what is that value right there? -9. So, how do I do it graphically? I go to y equals 7, and I see the x value of the intersection where the line I want, y equals 7, hits the line I have, -2/3 x plus 1. Everybody good? Algebraically and graphically? I hope so. We are going to practice 2 algebras first, and then we're going to practice some graphing. So these are algebraic, so I will do them in blue. There is our function. What is the first thing I am going to write? I am not going to write m of x. What am I going to write? M of 7. And then I'm going to write 4/3, and then what am I going to write here instead of x? 7 over 1 to make it easier, plus 2. What is 7 over 1? Or 4/3 times 7 over 1? 28 over 3, yes? Which is 9 1/3, right? Everyone agrees? 28 over 3, which is 9 1/3, plus 2. What is 9 plus 2? So what is 9 1/3 plus 2? 11 1/3. What is the point that would go on the graph? 7 and 11 1/3. Easy peasy, lemon squeezy. What is the next one I'm going to do? I am not going to write the m of x. What am I going to write? The m of 1. And that is going to equal what? 4/3 times what? 1 over 1 plus 2. What is 4/3 times 1? 4/3 plus 2, which is 1 1/3 plus 2, which is 3 1/3. What is the point that would go on the graph? 1 and 3 1/3. Right? And lastly, what am I going to write here? Can I write m of x? No. Can I write m of 5? No. What do I really write? 5. Because the m of x is 5. So this whole side is where the 5 goes, because that whole thing is worth 5. So I have 5 equals 4/3 x plus 2. What is my job whenever I'm faced with a single variable? Isolate it. So I'm going to bring that 2 over, and what will it become? 3, because it becomes minus 2. 3 equals 4/3 x. How do I get rid of that 3? Multiply both sides by 3. Now 9 equals 4x. Now what? Divide by 4. And x equals 9/4, which is also 2 1/4. What is the point that will go on the graph? 2 1/4, and 5. Does everybody feel they can do this algebraically? Remember, maybe your algebra is a little crappy, but that's different than not understanding this, right? Like what Damon, and I don't mean to pick on you, but when we moved that 2 over, Damon just multiplied, right? And I know you saw your mistake, right? So his algebra needs a little practice, but he understood that we were looking for an x value. Does everybody understand the difference there? Your algebra might need practice. That's okay. That's not what this is about. This is about knowing, are you seeking an x, an input, or are you seeking an f of x, an output? Everybody get it? All right, you try number 6. So you missed all the graphic stuff. While you're working next block, I'll erase all this and I will quietly say it into the mic as if I was teaching it to you. So it will be there, okay? With the dulcet tones of my voice. Because I know you all can't possibly learn math without hearing the lilting tones of my voice wavering through your eardrums. Which is a load of horse crap, but, you know. Okay? So I will do that. I will start that right now. Okay, ladies and gentlemen, so this is an x value on the f of x curve right there. So this says x equals -3, so I go out to -3, and this is the line I care about, and I can see that it crosses right there, which is -2. So the point on the graph is -3, -2. This is on the G curve, which I will highlight green. On the G curve, x equals 0, so I go to where x is 0. It is right here, and I see there is where it crosses the G curve, so it's 0, 2. So erase this so we can start again. F is -2. X equals -2. So I go out to here where x is -2. There's my line I care about, and I can see it intersects my f curve at -3. So it's -2, -3. Now this is different because this is not an x value. Y equals 1. So I go to where y equals 1, and now I've got this line. And you can see that it hits my f curve twice at +1 and -4, at 0 and -4. So I have -4, 1, and 0, 1. And over here, we'll erase that. We'll use pink. Y equals 3, so I got up to where y is 3, which is right here, and I see that it intersects my curve right there, which is -1. So the point is -1, 3. The last two, I will shrink this down so it is all visible on the screen at once. G of 4, that is an x value on the G curve. So I go to where it's 4. I go down and I see there is my intersection for -2. And on this one, that is a y value of -2. So I go to -2. Sorry. I go to y equals negative 2, and I see two intersections at negative 3, negative 2, and negative 1, negative 2. Alrighty, now lastly, functions can get a little messy. For example, f of x equals 3x, g of x equals x plus 2. If I wanted the f of 2, that would equal 3 times 2, which would equal 6. If I wanted the g of 4, that would give me 4 plus 2, which would give me 6. Now, what if I wanted the f of the g of 4? Well, the g of 4 is 6, so that would go right there. Hey, Mr. Radnine. So this is really, since the g of 4 equals 6, this is really the f of 6, which is 3 times 6, which is 18. So if I asked you to give me the f of the g of 7, what would you do? Well, you would start with g of 7, because that's in the middle. So the g of 7 equals 7 plus 2, which equals 9. Now this g of 7 we know is 9. So the f of the g of 7 is really the f of 9, which is 3 times 9, which is 27. So the f of the g of 7 is 27. Now, I asked you to do this with 3 functions. So we'll start with the 1. F of x equals 1/2 x plus 3. G of x equals 3 minus 2x. And h of x equals x squared. Why? When do you plan to be here for a whole class? Why? Everybody else has to be here for 6 hours a day to get their credit. Okay, then tell me that. No, you weren't. You said, my mom is coming to get me at 1. And I said, why? And you said, because she has to. That is not why. Then go and do that. I want the f of the g. Oh, wait, I did that the other way around. I want the h of the g of the f of 8. Where do you start? You start in the middle at f of 8. So, the f of 8 is, that becomes 8, that becomes 8, so the f of 8 is 7. So now this is 7. Now I go to the inside and I do the g of 7. This is 7, so this is 7. So this is 3 minus 14, which is negative 11. So now the g of 7 is negative 11. So now I need the h of negative 11. So this becomes negative 11, this becomes negative 11, and the h of negative 11 is 121. So the h of the g of the f of 8 equals 121.